Okay, lesson 2 of 6. We're still on grade 12 calculus. Now we are going to see the laws of differentiation or the rules of differentiation. Okay, so the first one is derivative of a constant function. Okay, derivative of a constant function. If f of x is equal to c, c is your constant, then f prime of x is equal to 0. Example, they ask you to determine f prime of x if f of x is equal to 5. F of x is equal to a constant, a number. When f of x is equal to a constant, any number, f prime of x is going to be equal to 0. Okay? You can have a question and ask yourself, how is this possible? Let's think of 5 as having a variable. Okay? You know that f of x can be written like this. F of x is equal to 5x to the power of 0. Okay, you know anything to the power of 0 is 1. So you have 1 times 5, which is 5. So we wrote 5 with a variable. Okay, the variable is x to the power of 0. Okay, so from this, if you have to take f prime of x, you can use the power rule. F prime of x is equal to, you start with your exponent, which is 0. You multiply it by your coefficient, which is 5. So you have 0 times 5, right? And then you have x to the power of 0. You subtract 1 from the exponent. Okay, this is the power rule, which we are going to see next. Okay, so from this, you know that this is equal to, you have this is 0, x to the power of negative 1. You have negative 1 there. 0 minus 1, which is negative 1. And so this is equal to, you have 0 times everything there. So this is equal to 0. Now you can see this is how we obtain f prime of x is equal to 0. Whenever you have a constant, a number. Okay, so now let's look at the next rule. Okay, the next rule is known as the power rule. Okay, if f of x is equal to x to the power of n, then f prime of x is equal to, the power rule is the rule that we have used here. Now f prime of x is equal to, you have the exponent is n and you have an invisible coefficient of 1. So you have n times 1, which is n, x to the power of n minus 1, right? X to the power of n minus 1. You subtract 1 from the exponent. So this is the power rule. Okay, so n is any real number. Now let's see an example. Example, determine f prime of x if f of x is equal to x cubed. Now f prime of x is equal to, you have your exponent is 3 and the coefficient is 1. You have an invisible coefficient of 1. So you have 3 times 1, which is 3x to the power of 3 minus 1. You subtract 1 from the exponent. So this is equal to 3x squared, right? 3x squared. So this is what you get using the power rule. Okay, let's see the next rule. The next rule is known as the constant multiple rule. The constant multiple rule. With a constant multiple rule, you have a constant multiplied by another function. Okay, for example, if g of x is equal to c times f of x, c is your constant and f of x is another function. How can you take the derivative? G prime of x is equal to, you leave your constant, you isolate your constant. So you are going to leave it. You just take the derivative of the function. You are going to have c times the derivative of f of x. So it will be c times f prime of x. This is how you can take the derivative when you have a constant multiplied by another function. Okay, let's see an example. For example, determine g prime of x if g of x is equal to 12x to the power of 2. Okay, in this case, you can see that 12 is your constant, 12 is your c, and x squared is f of x. So how can you take g prime of x? Okay, g prime of x. G prime of x is equal to, you don't touch your constant, right? You don't touch your constant, you leave it. So you are going to have your constant times, you only take the derivative of this, x squared. So you are going to have 2 times x to the power of 2 minus 1, right? 2 minus 1. You subtract 1 from the exponent. So this is equal to, you have 12 times 2, which is 24, x to the power of 1, right? 2 minus 1 is 1. So the final answer is 24x. Okay, now let's see the last rule, okay, which is the sum and difference rules. If h of x is equal to f of x plus or minus g of x plus or minus and so on. Okay, you have many function, right? One function plus another function and so on. Or you can have one function minus another function and so on. So how can you differentiate? How can you take the derivative? Okay, if h of x is equal to f of x plus or minus g of x plus or minus and so on, then h prime of x is equal to, you take the first derivative of the first function, so you are going to have f prime of x plus or minus depending on what you have. Okay, you can have plus or minus, and you take the derivative of the next function, which is g prime of x plus or minus and so on. Okay, so you just have to take the derivative of each function. You add or you subtract. Okay, let's see an example. Example, determine h prime of x if h of x is equal to this. So these can be looked as different functions. Okay, now h prime of x is equal to, remember you have an invisible coefficient of 1 in front of x. Okay, you must be aware of that. You have an invisible coefficient 1 in front of x. You have the exponent is 5. You multiply by the coefficient, which is 1. You have x to the power of 5 minus 1. Okay, you subtract 1 from the exponent. So you are using the power rule. Let's carry on. You have plus. Now you have the exponent is 3 and the coefficient is 2. So you have 3 times 2 and x to the power of 3 minus 1. You subtract 1 from the exponent. Let's carry on. You have minus. You have your coefficient is 3 and the exponent is 7. So you have 7 times 3 and then x to the power of 7 minus 1. Okay, let's carry on. You have minus. You have an invisible exponent of 1 there. Okay, can you see that? 1. So you are going to take 1 times a half. Okay, 1 times 1 over 2. Right? Times 1 over 2. X to the power of 1 minus 1. Okay, you subtract 1 from the exponent. We carry on. You have plus. You have the invisible exponent of 1. Right? The invisible exponent of 1. So you have 1 times 2. Right? 1 is your exponent and 2 is your coefficient. So you have x to the power of 1 minus 1. You subtract 1 from the exponent. Let's carry on. You have minus. You have the invisible exponent of 1, right? You have 1 there, the invisible exponent, and you have another one in front of this x, which is your coefficient. Okay, so you have 1 times the 1 in front of x, which is 1. Okay, and then you have x to the power of 1 minus 1. Okay, so h prime of x is equal to, you have 5 times 1 and x to the power of 4 plus 6 x to the power of 2 minus 21 x to the power of 6 right? And minus, this is a half, right? 1 times a half, it's a half. X to the power of 0, right? 1 minus 1 is 0, plus 1 times 2, it's 2. X to the power of 1 minus 1, it's 0, right? 0. Minus, you have 1 times x, which is x, and then x to the power of 0, this is 0. So you don't have to be showing all this if you are comfortable with time. Okay, so I'm doing this for you to understand where this is coming from. Okay, so let's carry on. H prime of x is equal to 5x to the power of 4 plus 6x squared minus 21x to the power of 6 minus, this is 1 times 1 over 2, right? This is 1 times 1 over 2. You have 1 over 2, right? Everything to the power of 0 is 1. So you have 1 times 1 over 2. You have 1 over 2. Plus, you have 2 times 1. This is 1 times 2. It's 2. Minus, this is 1. Okay, so this is 1, right? I hope you understand that everything to the power of 0 is equal to 1. Okay, let's carry on. H prime of x is equal to, so you have this part, right? And you have these are like terms. So you have 2 minus 1, which is 1, and then 1 minus a half. So you have plus a half. Okay, so this is the final step. So you have to know all these rules, right? You have to know this, this, and this. Okay, now we are going to see some notation for the derivative. Okay, if f is used, for example, if f of x is equal to this, then we are going to use f prime of x. Okay, using the power rule, this is equal to this. Now, if g is used, so you have g of x is equal to this, then you know the derivative will be written down as g prime of x. Okay, and you have this. Another example is they can use the letter h. Okay, let's say if h of x is equal to this, then the derivative will be written down as h prime of x. You know h prime of x is equal to this. Okay, they can also use y. Okay, if y is equal to x to the power of n, they can also use y. Then they are going to express the derivative like this. The derivative of y with respect to x, they are going to write it like this. And so this is equal to, or they can express the derivative as y dash. Okay, when they say y dash, they mean you have to take the derivative. And so this is equal to what you have there. Okay, another notation for taking the derivative is this one. When you have this, it means take the derivative of what you have inside the square bracket. And so this is equal to this. Okay, what you have there. Or they can give you this notation. When you have this notation, it means take the derivative of what you have inside the round bracket. Okay, and so this is equal to what you have there. Okay, now we are going to solve some problems. Okay, I've got 5 problems that we are going to solve. Okay, problem number 1, this is the question. And problem number 2, this is the question. And problem number 3, this is the question. And problem number 4, this is the question. And problem number 5, this is the question. Okay, we are going to solve these 5 problems. Okay, let's get started with problem number 1. Okay, so if f of x is equal to this, determine f prime of x. Okay, or determine the first derivative. Okay, solution. Before you can determine the derivative, you don't want to have the square root sign. Okay, so you have to get rid of the root sign. And you don't want to have the bracket. Okay, so you have to drop your bracket. You have to get rid of the root sign and you have to drop your bracket before you can take the derivative. Okay, f of x is equal to, right, you have that bracket. Now you have square root of x. You have to get rid of the square root sign. Okay, so let me show you how you can get rid of the square root sign. Remember, when you have this, to get rid of this root sign, this is equal to x to the power of a over b. the exponent is a, so you are going to have x to the power of a over b, a fraction like this. Okay, you know where your b is coming from. Okay, so we are going to do the same here. Now your exponent is 1. Okay, there is an invisible exponent of 1, and you have 2 there, an invisible 2 there, because this is square root sign. Okay, square root sign, it means you have 2 there. So this is x to the power of 1 over 2. Okay, I hope you understand where the 1 is coming and where the 2 is coming. Okay, the 1 is your exponent and 2 is your invisible 2, which is there because this is square root sign. Okay, so you have an invisible 2 there and the exponent is 1. Okay, let's carry on. Minus 3, you close the bracket. 2, you get rid of this. You're going to have x to the power of 1 over 2, right? This is the same. Okay, plus 2x. Okay, now you are done getting rid of the root sign. Now you have to drop your bracket. You are going to expand this. Okay, f of x is equal to, you have this times this. Okay, so the coefficient is 1. You have an invisible coefficient of 1. So you have 1 times 2, which is 2, x to the power of 1 over 2 times x to the power of 1 over 2. Okay, this is multiplication and you have the same basis. According to the laws of exponent, when you have multiplication and the bases are the same, you are going to add your exponent. So it will be x to the power of this plus this. Okay, 1 over 2 plus 1 over 2, right? A half plus a half, which is 1. Okay, so you have 2x, x to the power of 1. Okay, so we are done with this. Now we are going to take this times this. So you have plus 1, the invisible coefficient of 1, times 2, which is 2x to the power of 1 over 2, times this x to the power of 1. Okay, you have an invisible exponent of 1. According to the laws of exponent, you are going to add your exponent. Okay, 1 over 2 plus 1. Okay, this is 0.5 plus 1, right? 0.5 plus 1, which is 1.5. We are going to write it as a fraction. 1.5 is 3 over 2. Okay, so you have x to the power of 3 over 2. This is 1.5. Okay, so we are done with this. Now we are going to take negative 3. So you have negative 3 times this, which is negative 6 x to the power of 1 over 2, right? And then negative 3 times this, which is negative 6 x to the power of 1. Okay, so you have this. You are done dropping your bracket and you are done getting rid of the root sign. Now you can take the derivative. F prime of x is equal to, this is 2. When you take the derivative, please go back to the previous slide. In the slide, I have explained how to take the derivative. Okay, so this is 2 when you take the derivative, plus you have 3 over 2, the exponent, times this coefficient, right? 3 over 2 times 2, which is 3, x to the power of this exponent. You subtract 1 from the exponent. So this is 1.5 minus 1, which is 0.5. Okay, and 0.5 is 1 over 2. Okay, minus, now you have this exponent times this coefficient. The coefficient is 6. Okay, 1 over 2 times 6, which is 3, x to the power of this. You subtract 1 from the exponent. Okay, 1 over 2 minus 1, which is negative 1 over 2. Okay, minus 6. Okay, when you take the derivative, let's carry on. Now you can see this and this. These are like terms. Okay, 2 and minus 6. These are not like terms because you can see the exponents are different. You have 1 over 2 and negative 1 over 2. The exponents are different. These are not like terms. The like terms are 2 and negative 6. Okay, so f prime of x is equal to, you have this, right? Okay, 2 minus 6, which is minus 4. So we are done with problem number 1. Now let's move on to problem number 2. You have this. It means you have to take the derivative of what you have inside the square bracket. Okay, solution. So before you can take the derivative, you don't want to have x at the bottom. Before we can take the derivative, you have to get rid of this. Okay, so you have this. We are not taking the derivative yet. Okay, so you have to get rid of the x first. So we are going to factorize this. Okay, so this is what you have. We are going to factorize this and see if we can get rid of the x at the bottom. Okay, so let's factorize this like this. Okay, so you have x squared. You are going to have x times x, which gives you x squared. And you have negative 6 there. You can take 1 times 6, because from 1 and 6, you can have minus 5. You know that 1 minus 6, it's minus 5. So 1 and 6 will help. Okay, 1 times 6, it's 6. And from 1 minus 6, you have minus 5. Okay, so you are going to have plus there and minus there. Okay, over this, right? You close your square bracket. Now you can see this and this can cancel. Okay, so you have this and this. So you remain with this. Okay, so you have this is equal to this. Okay, so now so far we didn't take the derivative. We were trying to adjust this so that we can get rid of the x in the bottom. This is why you still have this. Once you start taking the derivative, you have to drop this. Okay, so this is equal to, let's take the derivative of what we have inside the square bracket. The derivative of this is equal to 1 plus the derivative of a constant. Remember from the previous slide, the derivative of a constant is 0. Okay, so your final answer is 1. Okay, 1 plus 0 is 1. Okay, let's move on to problem number 3. You are going to take the derivative of what you have inside the round bracket. Okay, so problem number 3, take the derivative of this with respect to x. Okay, solution, take the derivative of this with respect to x. Before you can take the derivative, you don't want to have x at the bottom and you don't want to have the root sign. So there are ways in which you can adjust this. Okay, let me show you how you can adjust this. So you can take each term above this line and divide it by x squared. Okay, you take each term above this line and you divide it by x squared. Okay, let me show you. So you have this. The first one is x to the power of 4 over x squared, like this, minus, you have this, over x squared, right, plus, you have this, over x squared. Remember, we are going to get rid of this. So it will be x to the power of 3 over 2, okay, over x squared, like this. X to the power of 3 over 2, and then over x squared, like this. Remember, as I showed you in question 1, this is what you have. To get rid of the root sign, remember this is equal to x to the power of a over b, right? A over b. Okay, so in this case, you have your exponent is 3, and you have an invisible 2 there, because this is square root sign. So it will be x to the power of 3 over 2, right? X to the power of 3 over 2. Okay, another way to adjust this, you can also do it like this. Let me show you. You can take this to the top, right? X squared to the top, it becomes x to the power of negative 2. Okay, so when you take it to the top, you are going to multiply by everything above the line. So it will be times everything there. This is what you have above the line. Remember, this is this. After getting rid of the square root sign, you have this, right? Remember to close this bracket that you have opened. Okay, close it. Okay, I'm going to choose this. You can do it like this or like this. I'm going to choose this. Okay, so this is what I have. Let's carry on. So this is equal to, you have this times everything inside the round bracket. Okay, so we are not taking the derivative yet. We still have to keep this. Okay, you keep this because you are not taking the derivative yet. We are still multiplying inside the bracket, right? You have this bracket. Now you have this times this. The bases are the same, and this is multiplication. According to the laws of exponent, you are going to add your exponent. So it will be x to the power of 4 minus 2, okay, which is 2. Okay, you are done with this. Now you are going to take this times this, right? You have an invisible 1 in front of x, okay? The coefficient is 1, right, in front of x. So you have 1 times negative 2, which is negative 2. Okay, the bases are the same. It will be x to the power of negative 2 plus 2. Negative 2 plus 2, which is 0. This is according to the laws of exponent. Okay, you are done with this. So now you have this and you have this. This is multiplication. According to the laws of exponent, when the bases are the same, you are going to add your exponent. Okay, so it will be plus x to the power of what? You add your exponent. Negative 2 plus 1.5. Okay, negative 2 plus 1.5. Or you can say 1.5 minus 2, which is negative 1 over 2, or negative 0.5. You are going to close your round bracket. Okay, and this is equal to this, right? You have this minus 2. This is 1. 1 times 2 is this, and you have this. So you are done adjusting this. Okay, now you can take the derivative. Once you start taking the derivative, you are going to drop this. Okay, once you start taking the derivative, you are going to drop this. So this is equal to, this is 2x, okay, when you take the derivative, and this is 0, a constant. Okay, you take the derivative of this, you have your exponent is negative 1 over 2 times your coefficient, which is 1. You have an invisible coefficient of 1. So negative 1 over 2 times 1, which is negative 1 over 2, right? Negative 1 over 2 times 1, it's negative 1 over 2. X to the power of, you subtract 1 from the exponent. Negative 1 over 2 minus 1, you are going to have negative 3 over 2. I hope you understand. This is negative 0.5 minus 1. This is equal to negative 1.5. So you can write it as a fraction, which is negative 3 over 2. Right? This is negative 1.5. When you subtract 1 from this, you have this. You can leave it like this, or you can change it to have your exponent positive. Instead of a negative exponent, you can change it. Depending on what they request from you, you are going to do it. Okay, so you can leave it like this. Let's move on to problem number 4. If s is equal to this, determine s prime of t. They are using different variables. You must not be confused with this. Okay, so the subject of the formula is s. Okay, the independent variable is t, and the dependent variable is s. Whether they use different variables, okay, you are still going to do the same. Okay, so you are requested to determine s prime of t. Okay, so solution. The other way to ask this question, they can say determine the derivative of s with respect to t. Okay, so you have ds over dt. S is equal to this. This is what you are given. You don't want to have the bracket. You have to drop your bracket before you can take the derivative. Okay, as we did it in this question. So s is equal to, you are going to take this times this. So the bases are the same, and this is multiplication. According to the laws of exponent, you are going to add your exponent. So it will be t to the power of this exponent plus this exponent. This is 0.5 and this is 1.5. Okay, 0.5 plus 1.5 is equal to 2. This is 2. Okay, you are done multiplying this with this. Now you are going to take this times this. So it will be plus 2t to the power of this. Okay, this times this, you have this. Now you are going to take negative 3 times this. It's negative 3t to the power of this. Okay, you are done with this. You are going to take negative 3 times 2, which is negative 6. So you are done. You dropped your bracket. Now you can take the derivative with respect to t. The derivative s prime of t, s prime of t is equal to, this is 2t, the same way as you did it here. You got 2x, so here it is 2t. You take the derivative of this, you have your exponent is 1 over 2 times the coefficient, which is 2. 1 over 2 times 2 is equal to 1. So you have plus 1t, right? You subtract 1 from this exponent. 1 over 2 minus 1, which is negative 1 over 2. Let's carry on. You have this exponent times this coefficient, negative 3. So you have 3 over 2 times negative 3, which is negative 9 over 2. T to the power of, you subtract 1 from the exponent. So this is 1.5 minus 1, you are going to have 0.5, which is 1 over 2, right? You take the derivative of this is equal to 0, a constant. Remember from the previous slide, when you take the derivative of a constant is 0. So this is the final answer. Let's move on to problem number 5. Now you are going to take the derivative of this, dy over dx. Take the derivative of y with respect to x. Okay, solution. So you don't want to have x at the bottom before you can take the derivative, and you don't want to have the root sign. You can leave this like this. You don't have a variable, or you can change it. You don't have a variable there. And here, you don't want to have x at the bottom before you can take the derivative. Here, you don't want to have the root sign before you can take the derivative. Even here, you don't want to have the root sign before you can take the derivative. You don't want to have the root sign, and you don't want to have x at the bottom. Okay, so let's do some adjustment before we can take the derivative. So y is equal to, you have 3 over 2 x to the power of negative 1. You take x to the top. Now you have x to the power of negative 1. And there you have negative 1 over 3. You are not changing anything because x squared is at the top. Plus, you get rid of this. It will be x to the power of 2 over 3. Remember this, okay? X to the power of a over b, right? X to the power of a over b. So it will be x to the power of 2 over 3. X to the power of 2 over 3, right? Minus x to the power of 3 over 5. Plus, you can leave it like this, or you can change it. You don't have a variable. This is a number. Okay, let me change it. So it will be 3 to the power of 1 over 2, right? 3 to the power of 1 over 2, like this. Plus, you don't want to have x at the bottom, so you are going to change it. It will be x to the power of negative 1. Okay, negative 3 x to the power of 1 over 2. Okay, x to the power of 1 over 2. I hope you are not confused. Minus 5x to the power of 3 over 2. I hope you understand where the 2 is coming from. B, right? You have an invisible 2 there because this is square root sign, right? Square root. So you have 5 times square root of x cubed. So it will be 5x to the power of 3 over 2. Plus, now you can see this 2 over, remember this is the same as this, 2 over x to the power of 1 over 2, right? When you get rid of this, so it will be 2 times, you take this to the top, it will be 2 times x to the power of negative 1 over 2. Now, the derivative equal to negative 1 times this coefficient 3 over 2, it will be negative 3 over 2 x to the power of negative 2 when you subtract 1 from the exponent. Okay, negative, you take the exponent times the coefficient, it will be negative 2 over 3, right? The exponent is 2 times the coefficient x to the power of 1 when you subtract 1 from the exponent. Plus, you take your exponent 2 over 3 times the coefficient is 1, so it will be 2 over 3 x to the power of, you subtract 1 from this. 2 over 3 minus 1 is equal to minus 1 over 3. You can check that. Okay, minus, you have the exponent is 3 over 5 times 1. The coefficient is 1. 3 over 5 times 1, which is 3 over 5. X to the power of 3 over 5 minus 1 is equal to negative 2 over 5. Plus, you have this. This is a number. You take the derivative of this. This is a number. So this is a constant. The derivative of a constant is equal to 0. Okay? Plus, you take the derivative of this. You have negative 1 as your exponent times 1. You have 1, an invisible 1, right? The coefficient is 1. So negative 1 times 1, which is negative 1. X to the power of negative 2 when you subtract 1 from the exponent. Let's carry on. You have minus 1 over 2 times 3, which is 3 over 2, x to the power of, you subtract 1 from this, so 0.5 minus 1, this is negative 0.5, so negative 1 over 2, right? Negative 0.5, which is negative 1 over 2. Let's carry on. Minus, you have your exponent is 3 over 2 times 5, so it will be 15 over 2, x to the power of this minus 1. Okay, you subtract 1 from this. This is 1.5, right? This is 1.5 minus 1. It's going to be 0.5. So 0.5 is 1 over 2. Let's carry on. You have negative 1 over 2 times this coefficient, right? Negative 1 over 2 times 2, which is negative 1. X to the power of, you subtract 1 from this exponent. So this is negative 0.5 minus 1, right? Negative 0.5 minus 1 is negative 1.5, which is negative 3 over 2 when you write it as a fraction. Okay, so let's carry on. The derivative is equal to, you have this part, right? You have this part, right? This part, can you see? Okay, plus 0, nothing change, and you have this part, right? Okay, so you don't have 0 anymore. Let's carry on. The derivative is equal to, you can see you have log terms, this and this. You can see the exponent is the same. Okay, the exponent is the same, negative 2 and negative 2. So these are log terms, right? Because the exponent is the same. You are going to add your log terms. Okay, so this and this, they are log terms. So you have negative 3 over 2 minus 1. Okay, negative 1.5, right? Negative 1.5 minus 1, which is negative 2.5. I can write it as a fraction, negative 5 over 2. So this is negative 2.5. X to the power of negative 2. Okay, these are log terms. So you have this. All 3 terms, they are not log terms, including this. These 3 terms, they are not log terms. You can see the exponents are different. So you have this part. Okay, this part, you can see. And you have this part, right? You can see. Okay, we are done with lesson 2 of 6. Please check for lesson 3 of 6. Okay, for now, we are done. Until next time, I will talk to you soon.